Hi future doctors, welcome to the next class. In this class, we will see what is polarization. So polarization is nothing but the single sideness of the light. How it is going to be coming, single sideness. What is that single side means? Always light is going to be traveling like this. If you are taking source of light, so many light rays we are going to take. How it is going to be taken means both electric and magnetic field components. That one only we are going to represent arrow component, and dot component. How this arrow and dot components they are going to represent? This is called unpolarized light. Unpolarized light, we have to make it into polarized. So this is going to be passing like this. So many plus shapes will be coming, will be passing like this. This is dot component. This is arrow component. If you remove this dot component, only arrow component is there. This is called polarized light. Otherwise, if you remove this, only dot component is there. So single sideness of the light, either arrow component should be there or dot component should be there. So this is going to be plain polarized light. Otherwise, this one also you can take. Only this one should be there. Now, if it is passing through one Polaroid, so this Polaroid I have taken like this, then it will be passing like this. Then, so only dot component is passing, arrow component is obstructed by this Polaroid. So only dot component is coming. Let us say. Otherwise, through this parallel it is there. Only arrow component will pass through this. Arrow component will pass, dot component will be obstructed. Therefore, only arrow components will be coming. So, this is called polarized light. If you are passing I naught intensity, so how much intensity will be coming means half of the intensity. So, in some goggles, so goggles we will use. So, in that we are going to use these Polaroids in 3D movies, 3D cameras. So, we are going to use this Polaroids to reduce the intensity of light. So, whether we got completely arrow components or completely polarized light or not, to cross check, this is polarizer, we will say. Polarizer. We will use analyzer, which is making angle between their axis. So, whenever they are taking analyzer, we are taking. So, all these arrow components will be getting stuck by this. Therefore, intensity is going to become 0. Therefore, we got completely polarized light. Even one arrow component came also, that component will be coming passing through this. Therefore, this is completely polarized light. So, whether we got completely polarized light or not, we are using by analyzer. Therefore, how much intensity is going to come? That is only, they gave one formula, Malus or Malus law they are going to say. I naught cos square theta. So, I is equal to I naught cos square theta they are going to say. But here what is this I naught and what is this theta? Very, very important. Theta is the angle between axis of this polarizer and analyzer. Here it is going to be 90 degrees. Therefore, there is no problem. I naught cos square 90, it is going to be 0. Now, what is I naught here? You should take means generally not this I naught. So, the intensity which is coming from polarizer, that is going to be I naught by 2 we should take. Therefore, here 0 you got, therefore no problem. So, in next, whenever we are getting formula, they will give I2 is equal to I1 cos square theta, or I is equal to I0 cos square theta, like this they will give. So, what you should take I0 means the light whichever it is coming from polarizer. Here I0 by 2 is coming, therefore I0 by 2 cos square 90, it is 0. Because it is 0, there is no problem. Sometimes they will make angle like this, polarizer angle, they are going to give some angle 45 degrees. At that time, you should take this I naught value as I naught by 2. So, this is about Malus law. So, you can get how much intensity through the analyzer by using this formula you are going to get. Next, polarization by reflection. Brewster's law we are going to say. So, when unpolarized light is going to be incident, unpolarized light means in that which components will be there? Both arrow components and dot components. So one particular angle of incidence, that is called polarizing angle. At one particular angle of incidence, reflected light is completely polarized. Completely polarized means only either arrow components, dot components will be there. Refracted light, it will be having unpolarized light. Both arrow components and dot components may be available. So at what angle of incidence reflected light is completely polarized? This angle we are calling it as angle of polarization. Angle of incidence equal to angle of reflection. And this R we are going to call it as angle of refraction. The angle between reflected and refracted ray, this is going to be 90 degrees, perpendicular, let us assume. So it is traveling from one medium to another medium, mu, A to medium. Then how the relation we are going to get means, we are going to use Snell's law. 1 sine IP is equal to mu sine R. So what is R means here? This total angle IP plus 90 plus R is going to be 180 degrees. Then R is 90 minus IP. Substitute here. So sin IP is equal to mu sin 90 minus IP. So sin IP is equal to mu cos IP. That is going to be mu is equal to tan IP. So this is nothing but Brewster's law. Malus law and Brewster's law. So this is the relation we are going to get from refractive index and angle of polarization. Already we came to know refractive index and critical angle. Mu is equal to 1 by sin c. Now we got mu is equal to tan IP. So they may ask what is the critical angle also. At the time sin c is equal to 1 by tan IP. C is sin inverse 1 by tan IP, otherwise sin inverse cot IP also. This is the relation for critical angle and angle of polarization. So this Malus law and Brewster's law, if you came to know, definitely you can solve problem whenever they are asking on this concept. So on this equation, they asked in 2025 in the toughest paper, easiest question. So, but we have to identify, so how many the type of questions are going to be present. Unpolarized light means this one, polarized light, plain polarized light or polarized light. So here always intensity is going to be half of original intensity through polarizer. How much intensity you are going to get? By using this equation we are going to calculate. Malus law, Brewster's law. These two, if you remember, you can solve any question from polarization. From the wave optics, 90% they will ask from Young's double slit experiment. So remaining 10% chance is there to get from either diffraction or polarization.